Okay, I'm back. Let us continue. Indicate if you're hearing me. All right, cool. So let us continue with the circulatory system, and the rest is really review. All right, so the heart. The heart is a hollow muscular organ that is approximately the size of an adult's clenched fist, made of specialized cardiac muscle. Work as two paired pumps. The septum divides the right and left side of the heart. On the right side is responsible for deoxygenated blood. Left side is responsible for oxygenated blood. Each side is divided into upper chamber and lower chamber. Upper chambers are the atriums, lower chambers are the ventricles. Right now, circulation. The heart receives its blood from the aorta. So the coronary arteries originate from the aorta. When the aortic valve closes, there is some runoff. That runoff enters the coronary artery and the heart muscle gets its blood supply. The right side receives deoxygenated blood from the veins. The left side receives oxygenated blood from the lungs. So the normal resting heart rate for an adult is 60 to 100 beats per minute, right? And I mentioned to you yesterday that if the heart muscle is very developed, then it will be able to stretch further. It can stretch further. It can accommodate more blood. The more blood it can accommodate, the greater the contraction, but the contraction will be slower. So a patient, or an individual I should say, can have a heart rate below 60, and that is normal for that person. So again, when we're looking at numbers, we have to look at the patient's presentation to see if how they are presenting matches the numbers. When the heart rate goes below 60 beats per minute, it is said to be a bradycardic heart rate. So that's bradycardia, right? When it goes below 60. If it goes above 100 beats per minute, which can occur when we're exercising, if we start to get anxious, if we're doing rigorous physical activity, right? So again, when it goes above the normal range, you have to look at the patient presentation. Does it match? Is this something I need to be concerned about? When it goes above 100 beats per minute, that is referred to as tachycardia. Now, the stroke volume is the amount of blood that is moved in one beat. That's what we call stroke volume. Cardiac output is the amount of blood that is moved in 1 minute, and that is based on how fast the heart is beating and what we call stroke volume, right? And if the heart rate is good and we have enough blood to circulate, then we will get good cardiac output or blood pressure, right? So the electrical conduction system causes smooth coordinated contractions, and contractions produce pumping action. So in a nutshell, for the heart to have a rhythmic contraction, it must come from a controlled electrical stimulus, right? So electricity from electrolytes regulate that rhythmic contraction within the heart. I'm not going to talk too much about it now. When we cover cardiac emergencies, I'll go more into the electrical system of the heart. Now, arteries. The arteries carry blood from the heart to all body tissues, right? So you have the aorta, which branches into the coronary arteries, which supply the heart muscle with blood. You have the carotid arteries, which supply the head, or upper portion of the head. You have the hepatic arteries, which supply the liver, renal arteries, which supply the kidneys, and mesenteric arteries, which supplies the intestines. The pulmonary artery carries oxygen poor blood to the lungs. Arteries branch into smaller arteries and then into arterioles. Arterioles branch into a series of increasingly smaller vessels until they connect to the capillaries. So everything I'm going through now is what I have explained prior. So we're just recapping. All right, now the pulse. A pulse is palpated most easily at the neck, wrist, or groin, right? So the pulse gives an indication of how well the heart is pumping. When we feel for a pulse, the best place to feel for the pulse is where it runs over the bone. So you're putting pressure on the pulse against the bone, and you'll start to feel the pulsation. And these are the pulsations that we will count to get the pulse rate. Right? Now, don't expect you to know all of those arteries right now, but there are some key ones that you definitely need to be familiar with. Certainly, temporal, carotid, in the neck, the brachial artery, the upper arm, radial artery, popliteal, behind the knee, dorsalis pedis, top of the foot, posterior tibial, goes to the heel. So there are some main pulse points that you will definitely need to know right off the bat. The others you can learn them over time. All right, capillaries. Capillaries connect arterioles to venules. Fine end divisions of the arterial system allow contact between blood and cells. Veins. Veins return oxygen-depleted blood to the heart, or deoxygenated blood, the same thing. The superior vena cava carries blood returning from the head, neck, shoulders, and upper extremities. The inferior vena cava carries blood from the abdomen, pelvis, and lower extremities. And they join at the right atrium. The spleen is an important organ. It's a solid organ, it's highly vascular, it's under the rib cage, it helps to filter the blood, and it has a storage of blood in case your body goes into the shock. As a result of that, if it is injured, the patient can bleed significantly from the spleen. We talked about the blood composition previously. So the blood is composed of plasma, that's a liquid portion that moves all of the components around. You have the red blood cells, which are important to infection, inflammatory processes, and the immune response. Sorry, red blood cells is erythrocytes, which is specific to oxygenation. You have your white blood cells, which is specific to the infectious process in the body, inflammation, and immune response. And they have the platelets, which are important to clotting. All right, now blood pressure. The blood pressure is the pressure that the blood exerts against the walls of the arteries, right? So when the ventricle contracts, there's a pressure that is generated. When the blood leaves the ventricle and is traveling in the aorta. There's a pressure that the blood moves against, right? So the pressure that is created when the ventricle contracts, that is referred to as systole or systolic pressure. And pressure is written as a fraction, right? So it's written as a fraction. The top number represents systolic, the bottom number represents diastolic pressure, right? So the systolic or top number is obtained when the ventricles contract. Bottom number or diastolic reading is obtained when the ventricles relax. But what is being measured is the pressure that the blood is flowing against in the aorta. Right? So systole, when the left ventricle of the heart contracts, it pumps blood from the ventricle into the aorta. Diastole, when the muscles of the ventricle relaxes, the ventricles fills with blood. Now, there's something also referred to as preload and afterload. Preload pressure is a pressure that builds up inside of the ventricles before the ventricles contract. That's what we call preload, right? So when the ventricles stretch to fill with blood and that pressure starts to build up, that's the preload pressure, and that is the relaxation phase. That's where we would get diastole. The afterload pressure is the pressure inside of the aorta that the blood is moving against. So the systolic pressure is the high point of the wave. The diastolic pressure is the low point of the wave. Right now, normal circulation in adults. It automatically is adjusted and controlled. What does that mean? So in order, the end goal of the circulatory system is perfusion, right? The circulatory system works in conjunction with the respiratory system. So the end goal is perfusion. Now, in order for the circulatory system to fulfill its part in that process, we must have an adequate blood pressure, right? And when I say adequate blood pressure, it's the same as cardiac output. And you learned prior to this slide that in order for us to have good cardiac output, the heart must be beating at the required beat, 60 to 100. There must be enough blood inside of the circulatory system, so you need to have the adequate blood volume. Your blood vessels must have good tone, so there must be good tone in the blood vessels in order to create the pressure that is needed to push the blood forward, right? And you have to have adequate stroke volume, so or ejection fraction, I should say. So enough blood must be ejected or pumped out of the heart to meet the demands of the body, right? So it is automatically adjusted and controlled. So that means if I am lying down, my blood pressure would be lower if I am lower than if I am sitting, right? So if I sit up, the blood pressure is going to increase. If I start to stand, the blood pressure is going to adjust. If I start to walk, the blood pressure is going to adjust to that. If I start to run, the blood pressure is going to adjust. So your body will make adjustments based on the type of activity that you're carrying out as it relates to your blood pressure, because you need a blood pressure within the body that can supply your core organs and the rest of the body, right? It's adjusted. Once that is good enough and the respiratory system is working well, then you will get adequate perfusion inside of the body, which is circulation of blood in organ or tissue in adequate amounts to meet the cell needs. So blood enters organs and tissues through arteries. Blood leaves organs and tissues through veins. Continuing with inadequate circulation in adults. The system can adjust to small blood loss, right? So if there is an opening in the network, the system can adjust, right? And once bleeding starts to occur, the first thing the body does is vasoconstrict the blood vessel, right? Then clots will start to form. And the more blood the more blood the patient loses, is the more areas in the body that will go through the process of vasoconstriction. So what the body is doing is trying to increase the blood pressure, right? So if the blood pressure falls, pulse rate increase, right? That's how the body compensates. So the system can adjust to small blood loss. The vessels will constrict, the heart pumps more rapidly, right? So if the blood vessel constrict, the pressure inside of the blood vessel is going to increase. That will eventually move the blood pressure upwards. With a large loss, so if the patient is losing a significant amount of blood, the vasoconstriction and the heart increasing, the heart rate increasing and the pressure going up is not going to work. And eventually the blood pressure falls. And once the blood pressure falls significantly, the body will start to go into shock. And shock in a nutshell is the reverse of perfusion, right? So, a matter of fact, shock is referred to as hypoperfusion, which is low perfusion. All right, now functions of the blood. Perfusion, right? Transporting oxygen, transporting carbon dioxide, transporting waste and nutrients, and of course, clotting, coagulation. Now, the last part of the circulatory system is it speaks about how the nervous system can control the circulatory system. So the heart doesn't primarily need the brain to directly regulate how it beats. It can do it on its own. So the heart has certain intrinsic properties, right? It has automaticity, it has contractility, and it has excitability. So in a nutshell, the heart can create the impulses that it needs, it can conduct impulses, and it can contract on its own, right? So once the heart is able to absorb the electrolytes that it needs, it will move on its own. It can contract on its own. It does not need the brain to direct that directly. However, in extreme circumstances, so when we're in extreme circumstances, the brain will try to directly regulate it, right? And the portion of the nervous system that is responsible for that is a division of the autonomic nervous system, which is referred to as the sympathetic nervous system, right? So you have the sympathetic nervous system. So this is where there is going to be some regulation initiated. I don't want to say it's direct control, but indirectly, right? So what is happening at this point is the adrenal glands sense that something is wrong in the body as it relates to circulation to the core organs within the body. So it has to do something to increase the cardiac output, right? So the sympathetic nervous system is also referred to as the fight or flight response, right? So there's a command that is sent to the adrenal glands. The adrenal glands will produce, go ahead and ask your question, Miss Lewis. The adrenal glands will produce epinephrine, which is the same as adrenaline, and norepinephrine, which is the same as noradrenaline. So if you see adrenaline is the same as epinephrine. If you see norepinephrine is the same as noradrenaline, right? And this is secreted to stimulate the heart and blood vessel. So what happens is, specifically, if the perfusion level to the kidneys fall, so when there's not enough blood going to your kidneys, and your kidneys, your renal system is very important because that's how your body get rid of waste. The kidneys or renal system is the toilet in the body. And if no water in the toilet, it can't flush, right? So water is very important. Yes, it can affect blood pressure, Ms. Lewis. So the adrenal gland can affect blood pressure. So there, no, I wouldn't say it can affect blood pressure, but it's not gonna make you develop high blood pressure. It will try to regulate your blood pressure when you're going into shock. So when a patient is going into shock, it's gonna try and regulate the blood pressure. All right. So as I say, first, the body picks up that there is not enough perfusion to the kidneys. When the body picks that up, the sympathetic nervous system, will be activated. I so address your question, Miss Lewis. The sympathetic nervous system will be activated, right? So the adrenal glands will now produce norepinephrine. So the first thing that comes out is going to be norepinephrine. And when norepinephrine comes out, it affects, let me write this down, alpha. It affects alpha receptors. Right? Alpha receptors. Let me enlarge that. Now, alpha receptors are found in your blood vessels, right? So alpha receptors are found in the blood vessels, and receptors are protein sites on it can be protein sites in cells, it can be protein sites within the blood vessels, right? That if stimulated can create a specific reaction. When alpha receptors are stimulated by norepinephrine or adrenaline in the blood vessels will constrict. If blood vessels constrict, the pulse rate is going to increase, right? If the pulse rate is increasing, then that means blood is going to the heart much faster. Blood will leave the heart much faster. So the body is trying to bring the blood pressure up. That's what the body is trying to do. So after the alpha receptors come out, after norepinephrine or noradrenaline is produced, the body will then release epinephrine or adrenaline. So the adrenal gland then release epi or adrenaline. Adrenaline will affect, let me write that, what we refer to as beta receptors. Right? So beta receptors. Let me enlarge that. All right. Now, beta receptors, you have beta 1 and beta 2. And this is how I remember it. Beta 1, you have one heart. Beta 2, you have two lungs. So beta 1, one heart. Beta 2, two lungs. So the beta 1 receptors will affect the heart directly, right? So the beta 1 receptors will affect the heart. Beta 2 receptors will affect the lungs. So this is how it works. When adrenaline is produced by the body and it starts to stimulate beta 1 receptors that are found in the heart, all of the functions of the heart will be increased. So everything that the heart does is increased when it is stimulated by adrenaline, right? So the strength of contraction, the rate of electrical conduction, the rate or speed of contraction, right? It's going to increase all of those functions. Why? Because we want to bring the blood pressure up. With the lungs, two lungs, beta 2 receptors. When adrenaline or epinephrine stimulates beta 2 receptors in the lungs, it causes the air passage to open up. So you are able to get more air with oxygen into the lungs. So the body is trying to increase the oxygen intake and increase the blood pressure at the same time. So that is how the sympathetic nervous system will regulate the heart or control the cardiovascular system. So let me go over that one more time. So if there is a problem in the body, so if the cardiac output for some reason drops, right, there's not enough cardiac output, and the body senses that the kidney is not getting enough blood flow, the sympathetic nervous system will be activated, right? Impulses will be sent to the adrenal glands, which will produce norepinephrine or noradrenaline first. When noradrenaline comes out, it will affect alpha receptors in the blood vessels. Once alpha receptors is stimulated within the blood vessels will start to constrict, and this will cause the pulse rate to go up. After noradrenaline or norepinephrine comes out, the body wants to sustain that function. To do that, epinephrine or adrenaline is produced, and that will affect beta 1 and beta 2 receptors. So beta 1 receptors are found in the heart, beta 2 receptors are found in the lungs. When the beta 1 receptors are stimulated, it increases all the functions of the heart. It increases the strength of contraction, the rate of electrical conduction, and the speed of contraction, right? When beta 2 receptors are stimulated in the lungs by adrenaline, the air passage opens up and more air can enter the lungs with oxygen. Right, so that's that in a nutshell. Right, let me look at this question now. No. All right, so if a patient has high blood pressure, Ms. Lewis, it doesn't necessarily mean that something is wrong with the patient adrenal gland. It can be it can be something else that's wrong while the patient is having a problem with the high blood pressure. It can be a build-up of cholesterol in the blood vessel. It can be an issue with how their body is regulating electrolytes and moving water. So numerous things can cause high blood pressure. The adrenaline, your body is not going to produce adrenaline or noradrenaline unless you are going into shock or you're getting ready to run from somebody or confront somebody. That's when it will trigger. Now, if you're nervous, it can activate your sympathetic nervous system. So if you're nervous about doing something, it can activate the sympathetic nervous system, which is going to cause your blood pressure to go up. If you do your blood pressure at that point, it would be above normal, but it's going to go back down once the epinephrine subsides. It's not going to be something that develops into chronic blood pressure problems. Right, so nervous system control. So the sympathetic, in a nutshell, will speed up the functions of the heart. On the other side, the parasympathetic will slow down the functions of the heart. Right, so you can have the sympathetic and the parasympathetic. And how I remember it, the S in sympathetic, I use that to remember speed. Right? Now, it's not only that you need to think about, there are some other things that you also need to consider, which I'm not going to go into that right now, right? We go into nervous system. We can probably touch on that. So the sympathetic, the S in sympathetic, I use that to remember speed. So that's going to be the portion of the nervous system, specifically autonomic nervous system, that will speed up the heart's function. The word para means half. So parasympathetic. If the S represents speed, then it's half speed. So it means that the parasympathetic system slows down the cardiac function. You see what was typed there? I wouldn't say it's like the response Michael Wilson. They work together to balance out each other, right? So in other words, if I am going to do exercise or do martial arts, the sympathetic nervous system is going to be needed for that task. If I have lunch and after I finish eating, the parasympathetic would take over at that point. If I'm sleeping at night, it's parasympathetic. right? So they work together to maintain a state of balance within the body. So as I stated before, your blood vessels have alpha adrenergic receptors, meaning they respond to noradrenaline or norepinephrine. The heart and lungs has beta adrenergic receptors, and it's beta 1 for the heart, beta 2 for the lungs. The parasympathetic nervous system also has effects on the cardiovascular system, but it's going to be the reverse. So the parasympathetic slows down the cardiovascular system functions, right? And both systems work together to maintain a state of balance. And I'm going to touch on this again when I cover nervous system. So I'm going to go over the division of the nervous system. This is just one area of the nervous system. All right, and it looks like nervous system would be next. So I don't think we're going to touch that. No. What time is it? Hold on, let me check something. Let me check something. Any questions? All right. Who can tell me what's cardiac output while I look at this timetable? What is cardiac output? Go ahead, Mr. Michael Wilson. Go ahead. Go ahead.
So this is blood moved in and out in 1 minute.
Okay. What influences cardiac output? Go ahead. Go ahead.
Cameron here. Heart rate and the stroke volume.
Okay. What do you mean by heart rate? What do you mean by stroke volume? In your words.
General.
Remember heart rate.
Sir Rufus.
Yes, go ahead.
John's there. So, heart rate, how much beats per minute the heart make, and stroke volume, how much volume of blood it push per one beat.
All right, good. Yep. All right, cool. So I just checked the timetable. I am supposed to be covering nervous system next. So let's get into it. All right. All right, so it's not gonna be very long, even though it's one of the most complex systems within the body. So the nervous system anatomy and physiology. The nervous system is perhaps the most complex organ or system within the body. It is divided into two portions. So you have the central nervous system, which consists of the brain and the spinal cord, right? And then you have the peripheral nervous system, peripheral away from the central unit, which consists of your cranial nerves and spinal nerves. And we have 12 cranial nerves, 31 pairs. Well, 12 pairs of cranial nerve, 31 pairs of spinal nerves. All right, so let's look at the central nervous system, specifically the brain. Right? Now, there are three divisions of the brain that you must be familiar with. Right? So you have the cerebrum, the cerebellum, and the brainstem. The cerebrum is the largest portion of the brain, right? And this is the area of the brain that is responsible for all of the conscious functions or voluntary functions within the body. Anything that you have to think about is gonna be the cerebrum, right? So the cerebrum is also divided into your right and left hemisphere. So the cerebrum is divided into the right and left cerebral hemispheres, right? Now the right side of the cerebral hemisphere control movement on the left side of the body. Right side of the cerebral hemisphere controls movement on the left side of the body. And the left cerebral hemisphere control movement on the right side of the body, right? Now, the right side of the cerebrum is responsible for the way your speech comes out. So the way the speech comes out is the right side of the cerebral hemisphere. The way you interpret and understand speech is the left side. So left side is interpretation and understanding. The right cerebral hemisphere is how that speech comes out, right? So that's the cerebrum. Now the cerebellum, not as large as the cerebrum, sometimes referred to as the midbrain, technically not really is, but now we'll get into that. The cerebellum, you will use the B and L. So use the B and L in cerebellum to remember balance and coordinated movement. So that's what the cerebellum is for. It's for balance and coordinated movement. Cerebrum is more conscious thoughts, right? The cerebellum is balance and coordinated movement. The brainstem is the most well protected area of the brain, and it is the smallest. And the brainstem is responsible for all life sustaining functions, your ability to breathe, how your heart works, that's brainstem, right? So the brain itself is divided into lobes, and if you know the bones of the skull, you know the lobes of the brain. So you have the frontal lobe, parietal lobe, temporal lobe, occipital lobe. When we go more into neurologic emergencies, we'll focus more on what each lobe is responsible for, right? Because that will be important to the management of a stroke patient, right? So that's the three divisions of the brain: cerebrum, cerebellum, brainstem. Now, the spinal cord exit the skull at the foramen magnum, right? Now, the spinal cord is the link between your brain and the rest of the body. So that's the link between the brain and the rest of the body, right? Now, as the spinal cord moves down the spinal column, you have nerves that branch out in the upper extremity or shoulder and upper extremity. You have nerves that branch out in the lower extremity. So the nerves that branch out in the upper extremity will control the upper limbs or upper portion of the body. You tend to have more control over that. The nerves that branch down to the lower extremity tend to have more control over that area. Now, that's the central nervous system. Then you have the peripheral nervous system, which consists of your cranial nerves and your spinal nerves. And the peripheral nervous system divides into the somatic and autonomic nervous system. The somatic nervous system is responsible for voluntary functions. The autonomic nervous system is responsible for involuntary functions, right? So the autonomic nervous system is the system that further divides into the sympathetic and parasympathetic system, right? So the somatic nervous system transmits signals from the brain to voluntary muscles. The autonomic nervous system is responsible for involuntary actions, and it's split into two areas, which we discussed earlier. We have the sympathetic nervous system, which is sometimes referred to as the adrenergic nervous system. And you have the parasympathetic nervous system, which slows the body. So one is fight or flight, the other one slows the body down. And sometimes with the parasympathetic, they will say rest and digest, right? Or feed and breathe. That's the parasympathetic. Fight or flight, sympathetic. Now, two types of nerves are within the peripheral nervous system. You have the sensory nerves that carry information from the body to the CNS. I have the motor nerves that carry information from the central nervous system to the muscles. And I think that would be it for nervous system. Now, I'm gonna stop here on nervous system. What I'm gonna do is, while you guys are on lunch, I'll do up a chart that will help you to better understand the nervous system. All right, so we are going to stop here for now. It's lunchtime. What time is it? Let me see. 5 minutes past 11. All right, come back at 1. We'll start back at 1 p.m.